Okay, hi students. In this lesson, we're going to learn how to write the formulas for ionic compounds and then name ionic compounds based on their ionic formula. If you can't remember how to do this from last year, then this should be pretty well explained through this video. So our learning intentions are to write ionic formula from the names of ionic compounds. We're doing this so that we can understand and interpret the chemical formulas we see in chemistry classes. And you know you have it when you can write ionic chemical formula for compounds like aluminium oxide, which has ions with uneven charges. Ionic compound formulas. These are the result of bonding between a positive metal ion and a negative non-metal ion. You already know this. The main rule is that the resulting compound does not have any spare charge, so it should be completely neutral. This means the charge of the positive ions is balanced out by the charge of the negative ions. To do this, there's a process when writing your ionic formulas. The first step is to write out the name of the compound clearly so you know what you're dealing with. The second step is to identify the ions which are involved. And the third step is to balance the positive and negative charges in the ionic compound using subscripts. The process is going to be shown over the next couple of slides for several examples. So the first example is sodium chloride. The first step would be to write out its name. That's this step right here, sodium chloride. The second step is to identify the ions in there. So we have a sodium ion and a chloride ion. We know that the sodium ion has a +1 charge because sodium is in group 1, and we know that the chloride ion has a -1 charge because chloride is in group 7. So we can then write the ionic formula, NaCl, in this case because the sodium has a +1 charge and the chloride has a -1 charge. The charges on the ions balance out without any subscripts, so the final ionic formula is just NaCl. This is reflected in its crystalline structure, shown in this picture here, because for every chloride ion, there is a sodium ion. The next example is magnesium chloride. So the first step is to write out its name, magnesium chloride, very clearly. The next step is to identify the ions. We know magnesium is in group 2, so we give it a +2 charge as an ion, and chloride is in group 7, so we give it a -1 charge. So when we write the ionic formula, we have to balance the +2 charge of magnesium with 2 chloride ions because the chloride ions only have a -1 charge. When we write this into the formula, we write the 2 chloride ions as a subscript after the chloride. So the final formula will be MgCl2. This formula is reflected in its crystalline structure because for every magnesium, there are 2 chloride ions. The final example we're going to do is aluminium bromide. So in aluminium bromide, we have the aluminium ion. This is in group 3. It has a +3 charge, but generally you should just try to memorize aluminium because most group 3s do not obtain an ion charge. Then we have bromide. Bromide is once again in group 7, so it has a -1 charge. So when we're writing the ionic formula, we have to balance the charges. The 3+ charge of the aluminium needs 3 bromide ions to neutralize it. When we're writing the 3 bromide ions out, we write them with a subscript 3 after the bromide. So the final ionic formula can be seen here, AlBr3. This once again is reflected in its crystalline structure with 3 bromide ions for every aluminium ion. So now you have to practice some examples. I'd like you to pause the video here, try these examples, and then I'm going to write up the answers here to see if you've got it correct. Remember to use the 3 steps. The first step in this case is done for you. Potassium fluoride is written out. You have to identify the ions and then put them into a formula by balancing the charges. So potassium has a K plus ion, and it has a fluoride ion. Fluoride is a -1 ion. These are in a 1-to-1 ratio of charges, and therefore it is Kf for the ionic formula. The next example we're going to do is iron 3 oxide. Iron 3 has a +3 charge. That's indicated by the 3 in the brackets. So it's Fe 3 plus. The oxide has a -2 charge because it's in group 6. When you're doing examples like this one, we have to balance out the charge, and that can be tricky because you can't just add a single oxide to balance out the charge of the 3 plus. In this case, you have to look for the lowest common factor for both, which is +6, which is 6. So in total, the ions are going to have a +6 charge, and the oxides are going to have a -6 charge. To do that, we have to add subscripts. So Fe2, because that gives a +6 charge for the ion, and then O3, because that gives a -6 charge to balance out the +6 from the ion. A similar thing can be done for aluminium oxide. So we have Al3 plus, and then we have oxide again, O2 minus, and if we look at the ionic formula, we have to balance out the +3 charge with a -2 charge by finding the lowest common factor of 6. So that will be Al2O3. The exact same ratio of ions in each of these. The last one is calcium phosphate, Ca2 plus. We know calcium is 2 plus because it's in group 2. And then the other one is phosphate ion, which is a polyatomic ion, PO4 3 minus. So you should know well and truly all your polyatomic ions by now. If you don't, then you need to revise them. So in this case, we're going to need more calcium than we have phosphate because the phosphate has a greater charge. We find the lowest common factor, which in this case would be 6 for both. So the calcium is going to be Ca3, and then the phosphate is PO4, and then 2. Because we now have -6 charge from the phosphate and a +6 charge from the calcium, they balance out. These specific examples are quite complicated: iron oxide, calcium phosphate, and aluminium oxide, and if you know how to do those, you're well on your way to understanding how to write ionic formula.